Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be going over problems 1 to 5 of the May 2014 Staar Algebra 1 end of course assessment for the state of Texas. Do visit our website at mathcodeserve.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's take a look at problem number 1. It says which situation can be represented by y equals 12x minus 4. So we have an equation right here, and we're given 4 options in verbal form, and the question is which one, when expressed in algebraic form or as an equation, will yield y equals 12x minus 4. So what I'm going to do here is I'm going to convert every single statement here into an equation, and we'll see which one is the same as y equals 12x plus 4. All right, let's start with option A. It says the number of eggs y in x dozen eggs are for sale after 4 dozen eggs are sold. So y represents the number of eggs sold after you had x dozen, right? So dozen is 12, so you have x dozen, that's 12x eggs. Okay, you have 12x, but you sold 4 dozen eggs, so that's minus 4 times 12. It's 4 times 12, that's what 4 dozen is. Okay, let's simplify this expression. So we have y, the number of eggs left after 12, after x dozen, 12 eggs, and then you took out 4 dozens from x dozen. Okay, so 4 dozen is 4 times 12, and that comes out to 48. So we can see that option A is close, but it's not exactly right, so that's not our answer. Let's take a look at option B. It says the cost y of buying X movie tickets that sell for $8 each. Now remember the formula for cost. Cost is basically given by the formula price times quantity, or you can say quantity multiplied by cost. By price. Okay, let's go ahead and reverse that. We can write this as quantity multiplied by cost, or cost multiplied by quantity. Let's write it that way. The unit price multiplied by quantity tells you the total cost. All right. So we have a total cost of y here, and the unit cost is $8 each. So the cost is going to be the price times the quantity. This is the price. How many tickets were bought? X tickets were bought. So when we do price times quantity, we're going to have 8 as a price times the quantity of X. You can clearly see that that's not the same as this option. Let's drop that. Option letter C says the cost y after a $4 discount of buying X t-shirts that sell for $12 each. All right, so let's find what the total cost is y. Total cost is $12 for each for $12 each for X shirts. So the cost is price 12 times quantity X, which is 12X. But wait a minute, there is a $4 discount. So what does discount mean? It means you subtract $4 from the total cost. Okay? So we can see that this is an exact match. This is exactly what we're looking for. The answer is option letter C. Let's take a look at option D just to solidify our skills of expressing algebraic equations from verbal form into equation form. So let's see. The number of inches y in an x-foot tree after cutting off 4 feet. So y is the number of inches left after you had an x-foot tree and you took off 4 feet from it. So y is equal to x minus 4. And we can clearly see that this is not a match. So option D is not the answer. The final answer is option letter C. All right, let's take a look at problem number 2. It says the scatter plot shows the number of free throws that different basketball players attempted and the number of the number that each player made. So there goes the scatter plot right there. It says based on the thread and the data, approximately how many free throws will a player be expected to make if he attempted 60 free throws? All right, so there are no points given for the 60 free throws, so we are asked to estimate here. So there are two ways we can do it. We can use the line of best fit, basically trying to think of the line that is kind of in between all of the lines, and then wherever it intersects this line right here, that will be the answer. Okay, so we're looking for um, the line that intersects this line, x equals 60 right here. So the line of best fit is going to be somewhere in the middle. You can use your ruler to kind of do the sketch somewhere in the middle between all the lines right there. All right, so that's kind of a line of best fit. Let's see how many lines we have on the bottom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And these ones are on the line. We can move that up a little bit. So you just basically make a wild guess as an estimate, basically. Okay, so we see that it's however way we draw it is going to be somewhere around here. Okay, so this is one way you can do it, and let's see what the answer is. If you go from 60 to the line and then you trace it to the y-axis, it's somewhere between 30 and 40. All right, so our answer is going to be option letter G. Now that's one way of doing it. Another way you can do it is you can just give yourself a range and then you find what the average is in your range. All right, so how do we do that? Let's clear out the points again. So I'll say, okay, I'm going to do this. I'll draw a line from the origin to the max point right there through the high points. So that's like my maximum boundary, and then I'm going to draw another line to the minimum boundary right here, something like that. All right, and then what I'm going to do is I'm going to take these two values that intersect and I'm going to find the average. All right, so I have one value here and then I have another value here. We're looking at 60, do not forget. Okay, so the number of free throws is going to be somewhere in between this range, so we can just average it to have an idea. So what I'll do is I'm going to take 20 and 50 and I'm going to average it, okay, to get like the midpoint value. So we're going to do 50 plus 20, that's 70. When you divide that by 2, you get 35. So that's a safe guess, right? Somewhere right there in the center. So that's another way of doing it. You can use your line of best fit, or you can basically create your boundaries and find the midpoint, and that should tell you a good estimate for your expected output. So the answer for number 2 is option letter G. All right, let's take a look at question number 3. It says, which table shows the same rate of change of y with respect to x as y equals 4 minus 5 over 8x? So we have a table. We want to see which table is going to generate the output if you make use of this rule right here. All right, so we have the rule. The rule is y equals 4 minus 5 over 8x. So what I'm going to do is I want to pick a point, an x value that's common to all 4. I'm going to plug it into this equation and see which one yields the y value that matches the corresponding y value in any of the options. Okay, so let's see what value is common. What y value is a good selection here? -1 is here and here, that's no good. -3 is here and here, that's no good. How about 2? We have 2 here, 2 here, 2 here. Oh, that's great. So we can use 2. We're going to use this ordered pair right here, this ordered pair, this ordered pair, and this ordered pair. So what we're going to do is we're going to plug in 2 into this function and see what the output is. Okay, is it going to be 8? Is it going to be 0.8, -8, or 2.75? I'm going to do this by hand first, and then I'll show you how to use your calculator to do this. Okay, so when x is equal to 2, y is what? That's the question. We have 4 options. Whichever one, whichever answer matches what we get, that will be the correct answer. Hope, assuming that we did our calculations correctly. All right. So let's go ahead and carry it out. Our computations, y equals 4 minus 5 over 8. Now instead of x, what do I put? I put in 2, okay, because that's our test value. So let's put 2. Okay, let's write this as a fraction. We can reduce this. 2 goes here once, 2 goes here 4 times. And if we reduce further, we have y is equal to 4 minus 5 over 4. 5 over 4 can be written as 1 and 1 and a quarter. Okay? If you subtract 4 minus 1 and a quarter, you can write this as 3 4/4 minus 1 and a quarter. And then 3 4/4 minus 1 and a quarter is equal to 2 and 3/4. 2 and 3/4 is the same thing as 2.75 in decimal form. Think about it. If you have 3/4, you have 75 cents, right? So which y value is 2.75? That's the question. It's not A. That's negative. That's 8. That's wrong. It's not B, because that's 0.8. That's wrong. Oh, voila, it's C right here, 2.75, because this table tells us that when you plug in x into your rule or the equation, you're going to get 2.75 as your output, and that's what we got with our computation. Option D clearly is wrong because you have negative 8, and that's not 2.75. So if you don't like this method I used right here, remember you're free to use a graphing calculator on your assessment. So what we're going to do is we're going to make use of a TI-89, actually a TI-83 plus calculator to do exactly the same computations that I just carried out here, okay? So what I'm going to do is plug in x into my equation. So we're going to do 4, calculator isn't working anymore, okay, 4 minus, now when you enter in fractions, please group them together using parentheses, 5 over 8 times x. What is x? We use the value of 2 as our x value, okay? So hopefully our answer should come out to 2.75. Let's see what happens. Boom, 2.75. All right, so one thing that tells you that it's a good idea to use a calculator here is you see those decimals there? If you see decimal options, that's an automatic hint that you might want to use a calculator to carry out your computations. Okay, so we can clearly see that this is the correct answer. Now let's try another input. Let's input 4. We should get 1.5 just to make sure. Okay, so 4 minus the slope, which is 5 over 8, times the x value, which is 4, and our answer is 1.5. So you see, we're confident that this is in fact correct. Okay. All right, let's take a look at question 4. It says a teacher will determine the total number of books to order for a class using the function b of n equals 4n, where n represents the number of students in the class. What is the independent quantity in this solution? So you remember your function notation? Your function notation basically tells you what the dependent and independent variables are. Okay, so let's take a look at an example. Let's say you have this notation right here, f of x. What does this tell you? Let's say f of x equals some constant. We don't know what it is. This right here tells you what the dependent and independent variables are. So let's say f of x equals 3x plus 2, for example, 3x plus 2. Now, the variable in the parentheses is the independent variable, okay? So this is the independent variable, independent. Just based on the notation automatically, this is the independent variable. And the variable on the outside is the dependent variable, dependent variable. So this is our f is dependent, our independent is x. So that's basically what the function notation is. What this function notation is telling us is that f has to take in independent and x in order to generate its definition. Okay? So the notation in it of itself is a giveaway. So we have b of n equals 4n. We know that n represents the number of students in the class, and says n represents the number of students in the class, and then b of n is used to calculate the number of books. Okay, so b is the number of books. So which one is the independent variable? Let's go ahead and declare our variables first. Let's just write it down here so we don't get it confused. So the teacher is calculating the number of books. B is the number of books. Number of books. You have to be careful here, we don't get things confused. And n, we're told, is the number of students in the class. It's easy to confuse variables. So n is a number of students. So which of these is the independent? Remember our notation here. The variable in the parenthesis is your independent variable. Okay, so the dependent variable is b. The number of books is dependent on the number of students, right? So this is a dependent variable, number of books, and then this is our independent variable, number of students. All right, so which one is our correct answer? The independent quantity is option letter F, the number of students in the class. Okay, total number of books to order is dependent on the number of students. You don't just randomly order books, right? Think about it. You order books taking into consideration how many students you have in the class. Okay, all right, so that's that. All right, let's take a look at question number 5. It says the graph of the quadratic function g is shown below. Based on the graph, between which two values of x is a 0 of g located? So what on earth is a 0? A 0 of a quadratic function as a x value is a value where the function cuts the x-axis. Okay, another word for 0 is x-intercept. Okay, don't confuse it with the y-intercept, please. So this is the x-intercept. Now, if the zeros are the number of times the graph cuts the x-intercepts, how many x-intercepts do we have in this situation? We have 2 x-intercepts, or 2 zeros. This is the first one, and this is the second one. Okay, let's call them z1 and z2. 0, 1 and 0, 2. Okay, so 0, 1 is between what? 0, 1 is between two numbers. What two numbers is it between? It's between -2 and -1. Does that make sense? The graph cuts the x-axis at some point between -2 and -1, all right, for 0, 1. And then for 0, 2, this 0 right here, the graph cuts the x-axis between two values. What are they? They are 4 and 5. So the question asks, based on the graph, which two values of x is a 0 of g located? Okay, so this function is g. So let's look at our options. -9, -8, we don't have that there. Scratch that. 1 and 2, we don't have that in our options. Scratch that. -7 and 5, that's a trap. -7 and 5 is represents a point that's around the y-intercept. We are not asked for the y-intercept here, so this is not applicable. And then option number D, 4 and 5. Voila, we have a match right there. Okay, so option D is referring to 0, number 2, because it intersects the x-axis between 4 and 5. Thanks so much for taking the time to watch this presentation. Really appreciate it. Do subscribe to our channel for updates to the remainder of this review series. And feel free to post a comment in the comment section if you have any questions or clarifications, or you have any suggestions to help us improve the quality of tutorials we're making for you. We'll appreciate a comment in the comment section. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.